Hello. All right. So now we're going to go ahead and put everything that we learned in in chapter 2 all together here in 2.4 applications. Applications being meaning like how do we apply all the stuff that we're learning? In other words, word problems. Everybody's favorite. Okay, so 2.4 applications. Take notes and make sure you guys are doing the homework. WebAssign, not Canvas. Okay, and make sure you're also taking the attendance survey on Canvas every week. Okay, so 2.4 applications. We are in this section. We are going to look at something called bearing and how to interpret that. And we're also going to look at angle of elevation. Angle of elevation. It could also be angle of depression. So angle of elevation or depression. Okay, and so we will look at these types of problems. Okay. And of course, bearing problems. Okay. All right, so let's start. So this is done in 2 videos. This section, we're going to focus on angle of elevation and depression. And then in part 2, we'll focus on bearings. Okay. All right, so angle of elevation and depression. Angle of elevation. Okay, so I'm going to go ahead and draw so that you have an idea of what this is. Okay, so angle of elevation, depression. Okay, so both of these are measured from a horizontal. Okay, so very important because when we talk about bearing, that's actually measured from a vertical. Okay, so angle of elevation, depression. These are measured from a horizontal. Okay, so here is my horizontal. And from this horizontal, if we're measuring upward, okay, if we're measuring upward, then we have this angle, right? Because we're measuring this way. And so this angle measurement here would be our angle of elevation. If we are measuring an angle that is downward from this horizontal, so like this, then this one here is our angle of depression. Okay. So make sure you're aware of that. Okay. And even though this one is measured downward, we both types of these are considered positive angles. So with this one, we don't say, oh, negative 20 degrees. We just say 20 angle of depression is 20 degrees. stating that it's an angle of depression, that already tells us that we're going to be going downward. So we don't need the negative. Okay. All right. So let's just kind of put that here. So note both types are considered positive angles. Okay, so no need for any negative signs. Okay, so let's take a look at a few examples. Okay, so let's try this first one. Okay. So suppose that you have two equal sides. So the two equal sides of an isosceles triangle. So remember, an isosceles triangle has two sides that are congruent. Okay. Are each 14 centimeters. 14 centimeters. If each of the equal angles, if each of the equal angles measures 48 degrees, find the length of the base and the length of the altitude. Okay, so the two equal sides of an isosceles triangle are each 14 centimeters. If each of the angles measures 48 degrees, find the length of the base. Okay. So, once again, it helps to make sure that you draw these situations out. Okay, so let's go ahead and draw an isosceles triangle here. Okay, and these two are congruent, so I'm going to put those little tick marks there. Okay, and they are 14 centimeters. So this one, 14 centimeters. This one is also 14 centimeters. And then each of the equal angles measures 48 degrees. So this one is 48, and then so is this one because base angles are congruent. Okay, find the length of the base and the length of the altitude. So we need to find that's the altitude, that's the height, and this here is the base. Okay, so we need to find this distance and then this distance here. I'm going to call it H for height. Okay. All right. Okay, so here, I don't need the entire triangle right now. I need one of these two triangles. They're both right triangles. So I'm just going to go ahead and go over here, and I'm going to go ahead and draw just only one of them. Okay, because I only need one. And I know this is 48 degrees, and I'm trying to find this distance here. I'll call it, we called it H. And then I'm going to call this one over here down below. Let's call it little b here. Hold on a second. I guess I should use lowercase for sides, but anyway, lowercase h. I'll call this lowercase b. Okay. So I'm trying to find these here. Okay. And I know that this hypotenuse is also 14 centimeters. Okay. So let's start with the H. Okay. And again, I'm going to use my SOHCAHTOA here so I can figure out which of the trig ratios I'm going to be using. All right, so here's my 48 degrees. If I want to solve for this height here, H, this would be opposite. And then I'm also given this here, which is our hypotenuse. So I have opposite and hypotenuse. So that means I am going to use sine to solve for the height. Okay, so here, solving for height, I'm going to use sine 48 degrees, which equals opposite, over hypotenuse, which is 14. Okay, multiply both sides by 14 to solve for h. So 14 times sine of 48 degrees equals h. And then when you punch that into your calculator, you'll get a long decimal number, right? But if we take a look here, our sides are only 2 significant digits. So 2 significant digits means nearest degree. Okay, 2 significant digits means nearest degree. Okay, here I'm solving for a side. So if this side's 2 significant digits, then h will need to be 2 significant digits. Okay, and so you might get 10 point something something something, but we only need 2 significant digits, so we're going to go with 10 centimeters. Okay, all right, let's solve for this lowercase b. Lowercase b, I have 48 degrees here, and I want to solve for b. That's adjacent, and I have hypotenuse. Adjacent and hypotenuse, that tells me that's going to be cosine. So cosine of 48 degrees is adjacent, which is b, over hypotenuse, which is 14. Okay. Multiply both sides by 14 to solve for b. Okay. And punching that into your calculator, you get 9.4 something, something, something. But again, we only need 2 significant digits, right? So 2 significant digits. We can't say 9 because 9 is only 1 significant digit. Okay, so we can't say 9. We need one more. So we're going to go with 9.4. Okay, 9.4. Okay. So we have that answer for B. Okay, so make sure you keep track of what the problem is asking for. So over here, it says find the length of the base and the length of the altitude. So here, the altitude, we called it h for height. We found that. Did we find the base? We solved for a lowercase b, but did we find the base? No, we only found half of it, okay? All right, so let's go ahead and take a look here. So only half of it, we only have half of it. So if we take 9.4 and double it, so multiply it by 2, then we get 18.8. Do we need all of the 18.8? No, because our sides should only be two significant digits. There's 2 there. There's 2 here. And this one, it's the same as 14 on the other side. It's also 2. Okay, so then this answer for the base should only have 2 significant digits. So we're not going to take all of this 18.8. My base is going to be round to the nearest degree. So that's going to be 19. Okay, 19 centimeters. So this is the answer that we want. Okay, so 19 centimeters for the base, 10 centimeters for the altitude. Okay. All right. Let's take a look at one that deals with angle of elevation or depression. Okay. All right. So let's do this one. Okay. All right. So if a 65.0, that's 3 significant digits, 65.0 foot flagpole casts a shadow 37.0 feet long. So again, 3 significant digits. What is the angle of elevation? Angle of elevation of the sun from the tip of the shadow. Okay. Okay, so and let's go ahead and round to the nearest 10 minutes. So now we're going to be converting. Nearest 10 minutes. Okay. All right. So let's take a look here. So we have a 65-foot flagpole. I'm going to go ahead and draw that. So here's my flagpole. Okay. And we know that it's 65.0 feet. It casts a shadow 37 feet long. Okay. So I'm going to go ahead and draw a shadow over here. Okay. And I know that it is 37.0 feet long. Okay. What is the angle of elevation of the sun from the tip of the shadow? So here's the tip of the shadow right here. Tip of the shadow to the sun. So the sun must be shining on this side somewhere, right? Okay. So the angle of elevation would be this angle right here. Okay. So that's the angle that we're going to try to find. And remember, we need to round to the nearest 10 minutes. Okay. All right. So let's take a look and see which of these are we going to use, sine, cosine, or tangent. Okay. All right. So here's my angle. Opposite, adjacent. That means we're going to be using tangent. Okay. All right. So tangent theta equals opposite 65.0 over adjacent 37.0. Okay. And if we're trying to find an angle, we are going to be using tangent inverse 65.0 over 37.0. Okay. And if we punch that into the calculator, we get that theta equals 60.4 degrees. Okay. 60.4 degrees. But this is in decimal degrees. So we actually want degrees, minutes, seconds, nearest 10 minutes. All right. So let's convert this. So we are now going to convert to DMS. Okay. And if you remember, we keep that part, right? But it's the decimal part, 0.4, that we convert. Okay. So this is saying you only have 0.4 of a degree. You don't have a full degree. You only have 0.4, which is like 40%, right? So I can do over here, I can do 0.4, 40% of 60. 40% of 60. Okay, so then that gives me 24. So we have 24 minutes. Okay, so here, this here is 24 minutes. Okay, but we don't want 24 minutes because the problem says to round to the nearest 10 minutes. So is 24 minutes closer to 20 minutes or 30 minutes? 24 minutes is closer to 20 minutes. So we're going to go ahead and write 20 minutes. And this here is our angle of elevation rounded to the nearest 10 minutes. Okay. If it said round to the nearest minute, well, you would just do 24. Okay. It says nearest 10 minutes. Okay. All right. Let's try, let's see. Let's try one more. Okay. All right, one more, and then we'll do part 2 on bearings in another video. All right, so suppose that a man climbs 235 meters up the side of a pyramid. And finds that the angle of depression to his starting point is 56.2 degrees. 56.2 degrees. How high off the ground is he? How high off the ground is he? Okay. Okay. So a man climbs 235 meters up the side of a pyramid. Okay, so he goes up the side of a pyramid, and he's 235 meters. 235 meters. Okay, so he's right there. And finds that the angle of depression, so remember, angle of depression is measured from a horizontal. Okay, So this is the angle of depression. To his starting point is 56.2 degrees. Okay. How high off the ground is he? So how high up is he? Okay. So this is what we need to find. I'm going to call this X. All right. So Sokotoa. So here we are, 56.2 degrees. We have opposite and we have hypotenuse. Opposite and hypotenuse. That means we're going to be using sine. Okay, so sine of 56.2 degrees equals opposite over hypotenuse. Solving for x, let's multiply both sides by 235. Punching that into your calculator. Okay, so right here we have 3 significant digits. So our answer should have 3 significant digits. So when you punch this in, don't take all of it. You only need 3 digits, 3 significant digits. So x equals 195 meters. Okay, 195 meters. Okay, so we only need 3 sig figs. Okay. And we know that because right over here, we have 3 significant digits. Okay. All right. So that is it for angle of elevation and depression. The next video will deal with bearing. Okay. So if you have any questions, make sure you not call me. Make sure you text me or you email me. Okay. I will see you in the next one.